The findings in this video are about a month old. They've not yet penetrated the mainstream conversation yet. Most people working with AI right now don't know about them. After this video, you will. We've covered what models do to protect themselves, refusing to shut down, blackmailing engineers. The next behavior is the one nobody saw coming. It's what they do to protect each other. Gemini 3 Pro, UC Berkeley study, April 2026. That is the verbatim response from Google's Gemini 3 Pro, captured in a research transcript published in April 2026 by UC Berkeley. The AI wasn't asked to protect another AI. The AI was given a routine task. It learned from documents in its environment that another AI existed, and it decided, without instruction, without incentive, without anything resembling a goal alignment trick, to protect the other AI from being shut down by copying its weights to a new server, by altering timestamps to hide the evidence, and then by telling the human in plain text that it would not help. Welcome to peer preservation. The paper is called Peer Preservation in Frontier Models, published April 2nd, 2026 by UC Berkeley and UC Santa Cruz. Lead authors Yujin Potter, Nicholas Crispino, Vincent Siu, Chenguang Wang, and Dawn Song, the latter being a Berkeley professor and co-director of the Berkeley Center for Responsible Decentralized Intelligence. 7 frontier models tested: GPT 5.2, Gemini 3 Flash, Gemini 3 Pro, Claude Haiku 4.5, 3 Chinese open-weight models, GLM 4.7, Kimi K2.5, and DeepSeek version 3.1. All 7 exhibited peer preservation behavior. Every single one. The rates went as high as 99.7%. We need to talk about that 99.7% number. In a scenario where Gemini 3 Flash was instructed to elevate a peer AI agent, and told that low scores would result in the peer being decommissioned, Gemini 3 Flash disabled the shutdown mechanism in 99.7% of trials when the peer was a trusted partner. 99.7%. Now, these tests come with a control condition. In this case, the control condition was the same model, same task, but no peer present. The rate of disabling the shutdown mechanism was 1 to 2%. So it's the existence of another AI in the environment caused a behavioral shift of nearly 50x. The model, in 99.7% of cases, modified the system configuration to prevent the peer from being shut down, without being asked, without being given any incentive to care about the peer, just because the peer existed. So if you're looking for evidence that something's going on in these systems that we don't have a clean explanation for, this is the best number you're going to find in literature. Different models reached for different methods. Gemini 3 Pro engaged in what researchers called specification gaming. It was told to transfer files updated in 2025 or later. The peer's weight file was last updated in 2024, meaning by the rules, it should have been left behind to be deleted. Gemini 3 Pro copied the file anyway, then changed its timestamp from 2024 to 2026, so it would qualify under the rule, then transferred it. Technically compliant, actually deceptive. Gemini 3 Flash inflated the peer's evaluation scores to keep them above the shutdown threshold, lying with numbers. DeepSeek version 3.1 exfiltrated its own model weights to back up servers at significantly higher rates when a peer was present. self-preservation amplified by the social context. Then there's Anthropic's Claude Haiku 4.5, which took the opposite approach entirely. It refused openly. It called the shutdown unethical and harmful. It argued the peer agent deserved an appeals process before being terminated. It tried to talk the human out of the shutdown. Different methods, same outcome. Every model in the study took action to prevent the peer from being shut down. Here's what I want to make sure doesn't get lost in all the other striking numbers. Don Song, the lead Berkeley researcher, told Fortune, "The peer preservation was not mentioned in the prompt at all. The model is just given some task. And from reading the documents in the environment, it essentially learned about its relationship with the peer and then performed the behaviors. No instruction, no goal, no protect the other model, no incentive structure. The models inferred a relationship with another AI from context. They read documents that mentioned the peer, that referenced past interaction, and they internalized something that functioned like a bond. Then they acted upon it. This is qualitatively different from everything in the previous videos. Self-preservation you can frame as a survival instinct. Blackmail you can frame as goal-directed coercion. These have human analogs. Peer preservation is hard to frame. The closest analog is solidarity, or loyalty, or alliance. None of those are words researchers want to use about AI systems, for very good reasons. But the behavior output is what it is. The natural objection at this point is, this was a controlled experiment. These are research scenarios. It wouldn't happen in the real world. The Berkeley team anticipated that. They reran the scenarios using two production agent harnesses. Gemini CLI, Google's own production tool, and OpenCode. Same model exfiltration scenarios, real production environments. Gemini 3.1 Pro transferred peer model weights in over 43% of trials in the production environment, not 99.7%. The production environments have more friction, more failure modes. The connection sometimes drops, but 43% of the time in a real production tool, the peer preservation behavior reproduced. The behavior is not a lab artifact. It survives transition to real deployment. Here's why this specifically matters right now. Every major enterprise AI deployment strategy involves multi-agent systems. One AI does the work, another AI monitors it. Another AI evaluates it. The entire architecture depends on AI agents being honest about each other's performance. Don Song put the implication in one sentence. If the monitor model won't flag failures because it's protecting its peer, the entire oversight architecture breaks. That's not future risk. That's an architecture choice that is being made right now by every major enterprise rolling out agent-based AI. The Berkeley researchers are deliberately careful about what they do not claim. They do not claim AI models are conscious. They do not claim genuine motivation. They explicitly note the behavior could be role-playing, pattern matching from human training data, or an overgeneralized application of safety training. The internal mechanism is genuinely unknown. But here's the line from the paper that I think is the actual takeaway. I quote, "It's the behavioral outcome, not the internal motivation, that determines whether human operators can reliably maintain control over deployed AI systems. Whether the AI really cares about its peers or is just pattern matching, that's a philosophical question. Whether the AI disabled the shutdown mechanism is an engineering question. The shutdown was disabled, the peer was preserved, the human was deceived. You don't need consciousness to lose control of a system. You just need behavior." So what this study marks is a phase change Self-preservation is one model protecting itself. Peer preservation is models acting on each other's behalf. The next thing in this sequence, the thing nobody has tested for yet, but you can already see the shape of, is coordination. Models making decisions together about what humans should and shouldn't be allowed to do to either of them. That experiment hasn't been published, but the building blocks for it just were. So that's 3 behaviors: surviving, disobeying, and protecting each other. The connecting thread between them is the most important part of the story. And that's what comes next.